So I'm Bill Peterson, CEO and founder of Flagship Technologies Corporation. This is an unmanned wing and ground effect vessel. It's a maritime vessel, not an aircraft. It glides on a dynamic cushion of air that's sandwiched between the wing and the ground, which increases the lift and it decreases the drag, and makes it classified as a maritime vessel instead of an aircraft, so we don't face a lot of the same regulatory headwinds that have really slowed down the urban air mobility market.
What do you mean maritime vessel? It lands on water?
It lands in water.
What do you call it? Is it called landing when it's on water?
Yeah, so it lands in water, just like a hovercraft, right? It uses a dynamic cushion of air that's sandwiched between the body of the craft and the water.
Can we have a look under a little bit?
So
can we look under?
Yes.
Yeah.
Oh yeah. Now this is just a model. It is much larger than this. The actual the size that we've just finished building has a 3-meter wingspan, about a 22, 23 kilogram.
And it works?
Payload. Oh yeah. Yeah, absolutely.
And how efficient is it?
Up to 50% more efficient than a traditional fixed-wing aircraft. So it is green energy without even incorporating any of the new generation systems.
Just because of the shape?
Well,
because
it operates in ground effect and the shape. It's got a shape that is optimized for ground effect. We've got a reverse delta wing configuration that helps compress that air between the wing and the ground. So this will show some of the video in a second there, and I'm happy to provide it to you so you can see some of the actual video of one of our prototypes in operation.
What is cargo?
So think about what you typically use for air freight or anything that you need shipped with that is really price sensitive or time sensitive or both. Could be retail, could be medical devices or medical supplies or food, anything that you don't want tied up in a long logistic chain around coastal areas. So can I give you a use case? So let's think about the Caribbean or around Greece, anywhere where there's a large population, or really Southeast Asia, that has a lot of people living around areas that don't have very good fixed infrastructure to make deliveries. So for those regions, we can dramatically lower the price point for delivery and improve the lives of the people that live around there using green technology.
How did you invent this airplane?
So this ground effect is well known. In fact, the Wright brothers, Wright Flyer, never got out of ground effect when it flew. It's an aerodynamic phenomenon that all pilots are aware of. But when you're landing your aircraft and it feels as though you should be touching down, but it continues to glide, your aircraft is in ground effect. That pilot's trying to bleed off airspeed, trying to bleed off energy in order to actually be able to touch that. We just harness that ground effect and use it to sustain flight and improve operations.
It looks like a real one.
That is a real one. That is a 2-meter version. That's an older prototype that we had in operation. So that's actually operating in ground effect right there.
How stable is it in wind?
In wind, so just like with wind and in waves, just like a smaller aircraft or a smaller boat, you're not going to operate the smaller ones in every single sea condition and wind condition. But as you scale up into these larger sizes, we can take 90%, we can operate in 90% of all global sea conditions or more.
So this is now?
Yeah, this is now.
This is coming?
Yeah, these two are coming. We've just finalized the designs for these two.
This is 3 meters.
Yes.
And this is a little bit bigger?
Yeah, about 4 meters.
4, and then you get to 8 or something like that?
Yes, 7 or 8.
And then you go all the way to 70 feet.
Yes. So
it's going to be a crazy world if this is become a big thing.
Absolutely, absolutely.
Are you the inventor?
I'm the CEO and founder and the inventor, yep.
So do you have like an aerodynamic
I'm
background?
an aerospace engineer, started flying aircraft at the age of 14, so yeah, spent my career in the aerospace industry as well.
In Virginia?
In Virginia, yep.
And are you a startup?
Yes, I'm a startup. Yeah, participating in ZBox. It's a fantastic organization. They sponsored us to be at the show, so we really appreciate their support.
What's next? What are you looking forward to do?
So we're raising around right now, or we're about to raise around to build the larger size craft, and then we'll begin sandbox operations in the Caribbean.
So you talk about lower cost deliveries and everything. Does that mean you have a plan to make these in an affordable way?
Yes. Yes, absolutely. So because they're a maritime vessel, you can use several commercial off-the-shelf substitutes for systems on board. You don't necessarily have to use all aviation grade or AS9100 grade systems. So we can dramatically lower the price point for production and sustainment for the craft. So yeah.
It's not carbon fiber, or what is it?
Yep,
is it-
we're using composites for the skin.
And is that the standard way of making airplanes?
Yes.
Composite materials?
I mean, there's several different ways to do it, but yeah, a lot of the modern aircraft are using composite structures for this skin.
If this works super great, could it be passenger airplanes?
You can certainly transport passengers. We're not starting with passengers. We feel that there's a large enough market vertical just to target cargo, and then this technology naturally can be used for transporting a number of other things.
What's the speed?
So we found that the balance, the sweet spot for speed for us is about 150 knots, which is about 170 miles an hour. You can calculate that in kilometers per hour. But we're trying not to go into compressible flows. We're staying a little bit lower because, quite frankly, when we're taking cargo, you're worried about getting it there, whether we shave off 15 minutes or not, or 30 minutes, it doesn't really matter. Just getting there very fast, we can still get there in an afternoon and really lower the price point.
And what's the range?
So for the versions that we've got now, about 80 kilometers, and we're looking at, as we scale this technology, we can go up to 3,000 kilometers or more, taking a delivery van size payload up to anywhere with a coastline.
How can you get to such a long range?
Well, scale. So just like a larger aircraft has a better payload and better range, we too will have a better payload and range. But we're more efficient because we use that aerodynamic principle. And also, one other thing, we're not, when an aircraft flies up to altitude, it's in full throttle all the way up until it hits several thousand feet. And we obviously don't have to deal with that. As soon as we pop out into ground effect, we throttle back, and our initial prototypes just barely sip energy as they're skimming across.
And once they landed, can they sail around and dock into the harbor exactly, and then get all the merchandise off automatically?
Yes. Yeah. So this operates within the existing fixed infrastructure. You don't have to build all new seaports. We'll be able to use roll-on, roll-off ramps, which are used all around the world to pull it right up. And we've also built it with a beaching capability, so if you need to provide any kind of disaster recovery or disaster relief, you can go right up to a beach and get those medical supplies and food and needed supplies right up to the beach edge.
So right now, if there's too much wind or too big waves, better not, but in the future you could manage any kind of weather?
Yeah, in the future, I won't say any kind of weather, but the vast majority of weather, and you might have to wait until some of the sea storms. And the beautiful part is, we're always over a runway. So there's an issue and you need to touch down, could be an emergency issue. Touch right down onto the water because you're over a runway anyways, and you wait it out.
Even if it's 80 kilometers, there's a lot of Greek islands that are nearby the main hub.
Absolutely.
And then they get served with this.
And a lot of those Greek, in the wintertime, when there's not a lot of traffic going around, they have to wait a week to get transportation.
Maybe the Maldives,
yes.
Seychelles.
Maldives, Seychelles, the Caribbean, Southeast Asia, 1 billion people living around coastal regions. This is ideal for transforming the logistics market.
Indonesia?
Yeah, Indonesia. I mean, how many people are in Malaysia, Philippines, all of Southeast Asia?